Hi, I'm Adam. Welcome back to Godot Game Lab. This is the one final episode that concludes the AutoBattler course, and it won't be too flashy. There's no architecture overview or demo or anything, because in this episode we are just doing some minor refactors to future-proof the code and fix some issues where I disagree with past Adam, who made those lines of code in the first place, and also we are fixing some bugs. So let's start with the refactors first, because they are not bugs, so to speak. These are just small things that I found a bit annoying the way we implemented it in the past. And the first thing is something that has to do with items. So if we go to the script tab, press Ctrl-Alt-O and search for item.gd, here we have two methods called apply modifiers, and if we scroll down we have remove modifiers as well. If you remember, we are in item.gd, which is a resource, right, that represents the item that we have. And if we double click on apply modifiers, press Ctrl-Shift-F and search for it in the whole project, what you'll find is that we use this in the battle handler in two places. The first one, if we click on it, is when we add the items to the game from the planning units to the battle units when we spawn them. And this is fine, it works perfectly well. But the thing that I dislike about it is that it relies on a battle unit, right? And why do you think this might be a problem? Well, for now, the tooltips in the game are pretty easy and pretty bare bones for the units. We don't display all the stats, and also the stats that we display don't take modifiers into consideration. And if you were to do a full-on AutoBattler game, you probably want the health and the mana to display in a way that it also takes modifiers into consideration and displays the correct number, right? And when you implement that feature in the future, you just assume that, okay, I have an apply modifiers and the remove modifiers method in the item that I can use, but you can't really do that, right? Because it relies on a specific battle unit instance to apply those modifiers. And we know that non-battle units also have modifier handlers, right? So the refactor that we can do here is to change that outside dependency from a battle unit to a modifier handler, which makes it more generic, while at the same time I think it also makes more sense, right? Because modifiers should be applied to a modifier handler. And in this case we get an error message. We can't really do battle unit.modifier handler.get modifier, but the code actually becomes simpler because we just need to delete battle unit dot and change the modifier handler to mod handler, because that's the name I used for this parameter. And one thing I found also really odd in this code, if you take a look at it, we have this variable called mod value, which stores the modifier value for that modifier type that we have. And we kind of do the same thing when we pass this parameter to the add new value method, whereas we have this mod value as a variable. So why do the same thing twice? It's redundant. So instead of this, we can just reference that mod value, right? Especially because we set the unique identifier. I think this was just a typo. From my end, it makes sense to use the same variable. And when we do this, we kind of have to do the same thing for the remove modifiers, the counterpart of this. And again, we can just grab this modifier handler parameter now and change from the battle unit to a modifier handler. Again, copy this and replace this whole thing with mod handler.get modifier. And I think it's a small refactor, but it makes a lot of sense to me. Now, if we save this, the problem is that we use these methods and they still use the old signature where we had the battle unit. So if we double click on apply modifiers again, press Ctrl-Shift-F, click on find, you can see that we only use this in the battle handler. And if we do the same for the remove modifiers, I suspect that it will be the same. Yep, the battle handler. So let's move to the battle handler and find those uses. And it will be easy to find because if you take a look at the whole code structure here, we have the error messages throughout because we pass in the wrong type of data. But really all we need to change is from battle unit, we just change this to battle unit.modifier handler, same here and the same here. And we removed 3 of those errors. Now we just search for apply modifiers. Yep, and we have this new unit. When we add the items and instead of new unit, we just say new unit.modifier handler. Save everything with Ctrl-S and run the project to confirm that everything still works. So if we add a new Robin, maybe a Björn as well, add a gloves to Robin, and I don't know, maybe a ring to Björn, because we can definitely see then if the bonuses are applied. Robin shoots like crazy, and Björn Also, the swing is very powerful. So I suspect that everything still works. We don't have any error messages on the output or anything like that. Now, in this version of the project, which we land on or which we finish at, it doesn't really matter that much because the old solution was fine. That's why I did it the way I did it. But if we think about the future or where we can take this project, I think it makes sense to change this. Now, I'm pretty sure we could do this all day because I can always find small bits and pieces in my code that I can improve on. At some point, you gotta just say that, okay, it's fine for now. I will show you two other small things that we changed before we move on to actual bugs. One of those is the bench items. So if we go back to 2D view, press Ctrl-Shift-O and search for benchitems.tscn. What we do here is we have the item slots. And if you remember the script, if I click on the script icon, we have a constant reference to the bench item scene. And we use instantiate to spawn them in. See, the problem is, it's fine, by the way, it's just 40 lines of code, but for that exact use case where we have a pack scene and we spawn them in at some point in the code, we created a scene spawner component which we could have used here, but I didn't. So let's change that and click on the bench items, the root node, click on a plus sign or press Ctrl-A to add a new node and search for scene spawner. And for the export variable, the scene slot, let's click on the arrow and quick load and search for bench_item. And now we have this, right? So we need to change the bench items script to reflect those changes. First of all, we don't need that constant reference anymore, right? Instead, what we need is an already variable reference to the scene spawner. So I just drag and drop it here and release while pressing and holding Control. Now we have an already variable reference to the scene spawner. And inside the ready callback, we store these marker 2D children as the slots where we can actually instantiate items at. Now we need to change this because it loops through all the children and adds them all as slots, but it's not working anymore, right? Because we have a scene spawner child as well. So instead what we do is say that we loop through the child nodes and they won't be marker 2Ds necessarily, but we know for sure that it will be nodes. So it makes sense to rename this from marker to node. And slots.append node is fine as well, but we need to make a filter to make sure that it is a marker 2D before adding it to the slots array, this one. So before this, let's just do if node is marker 2D, indent this one more level, and we're fine. So this change is needed so the scene spawner child node won't be added to this array. And now when we scroll down where we actually add the items, we can replace these two lines of code with just saying scene spawner.spawn scene, and the parent will be the slot that we grab for it. And that's pretty much about it. So we changed this here. And if we scroll up, we change this storing of slots and grabbed an already variable reference to the scene spawner. Now if we save the script with Ctrl-S, run the game again, the spawning initially works. And if we just, add a gloves to Robin, then decide to sell him, it spawns it back. Let's just try a couple other items. Drag the sword to Robin. Now we have the sword and we have the gloves on Björn. So if I sell Björn, the gloves gets re-added and the sword as well. Okay, that was a small refactor, but I was like, if we have the scene spawner component, why not use it, right? When it's the right use case for it. Now, another thing I wanted to change and simplify has to do with inner classes. And for the detailed tooltip, in the last episode, if you remember, we did something like this. We did this detailed tooltip data inner class, which holds the reference to a bunch of data that we need to instantiate a detailed tooltip. When I was reading the documentation for the video, this example line of code really grabbed my attention. So when we define member variables for an inner class, we can just as well define or provide a default value for them, like we do with usual classes, right? With non-inner classes. Why does this matter? Well, if we go back to our project here, press Ctrl-Alt-O and search for detailed tooltip. And if we scroll down to the inner classes definition, you see that I haven't really used that feature. I just sort of listed all the variables that we need. And instead what I did is I did this setup function, which is kind of unnecessary because what it does is it changes the tooltip data member variable to another variable, which is a parameter for this method called data. And we could do this directly, right? I could set this data directly. The reason why I did this setup method is to sort of handle the minimum size X differently than all the other three data components, just so we don't have to provide a minimum value on the X and it defaults to 0. But this whole thing is superfluous because I can just do this, right? Min size X equals to 0.0 by default. And then it makes no sense to have this setup function at all because I don't need to handle this differently. So I don't need another parameter. And if I just do this, then why make it its own method if I can just set the member variable directly, right? It's not starting with a leading underscore indicating that it should be private, so we can just set it from the outside. So we don't need this setup method at all, which simplifies things a lot. And I think when you take a look at the inner class's definition, it really is descriptive, right? I can see that the default value should be 0.0 when I create a new detailed tooltip data. So right now what we need to do after this very small refactor is look for this setup method where we call it and just remove it. So with the setup and the opening parentheses selected, press Ctrl-Shift-F. And if I make this a bit bigger, you'll see that I use it in the trait UI, the bench item, and the item UI. 3 different places. So let's change them one by one. Click on the trait UI one first. And here what we do is we call this setup method and set the minimum X to 150. So instead what we can do is we can say above it that data.minsizeX should be equal to 150. And instead of new tooltip.setup data, we can just do new tooltip.tooltip data, that's the member variable, should be equal to the data we just created, right? Like so. We just set it directly. There's no need to introduce a new method anymore. Save this with Ctrl-S, go back to the search results, refresh it. Let's go to the bench item. And here we want to use the default 0.0, so we don't even need another line of code. We just do new tooltip data equals data, like so, right? Save it with Ctrl-S, go to search results, refresh it, go to item UI, hide the search results, and just here we use 0.0 as well, so we can just do new tooltip.tooltip data equals data. Save it with Ctrl-S. And if we go to the search results, now the only place where we have a reference to this is the definition itself. So if we go back to the detailed tooltip, we can safely delete this method. Now, again, this is a very small refactor, but I think it makes the code much cleaner, right? There's no need for an extra method when we can just do this. Now, these are all the small tweaks and changes I noticed when editing the previous video. Probably, as I said, there's like 100 more things that you can change or make better or refactor, but at this point, I would say that the code is pretty okay. I'm kind of happy with it, so let's just move on to fixing bugs instead, because those are a bit more interesting in my opinion. Now, for bug fixing, we'll have a bunch of bugs that I discovered. I have some that came from emails you guys sent and also have some issues opened on GitHub. So we have this weird cocktail of bugs, and we have 2 very peculiar and very interesting bugs that I think are a great learning experience. I'll leave these for the end of the video because those are a bit harder. Let's start with the easier ones, right? To warm up to the harder ones. Now, if we go back to 2D view and play the game, one thing I don't really like is when you buy units, right, and put them on the board and stuff, you'll see that all units have these weird like full health bars, and the mana bars just say 0, and also the tooltip says 0 out of 0. It is very weird in my opinion. Even though it doesn't matter that much, but when we start the battle and pause the game, it instantly updates the information to the correct one, right? The health bars are full. Björn has some starting mana, while Robin doesn't, so I think this information should be displayed correctly in the planning phase as well. So if we keep playing the game, let's add some AP to Björn. So if we win the battle and move on to the planning phase, it resets to this weird default position, right? And it doesn't really update the stats for the unit. Now if we press Ctrl-Shift-O and search for the unit scene, you'll see that this is the default value that we have in the editor as well. So it feels like it's not really updating. And I don't really think there's any reason why it shouldn't update, right? So let's fix that. It's not a bug per se, but I think it makes the game much nicer. So while we have the unit open, we can click on the script icon here to see its script better. And let's right click on it actually and close all the other tabs to keep things tidy. One thing that's really peculiar about this, and I think we made this a while ago. So this unit class dates back to the very early parts of this course. Now for the health bar and the mana bar, we have their own class names, right? So I don't see any reason why these should be progress bars as types. So the health bar could be health bar and the mana bar can be mana bar. They have their own class names, first of all. So let's change that. And if we scroll down, we have this setStats method, which is a setter function when we change the unit stats resource attached to these units. Now, since this is a tool script, we have this if here to run code that executes only when we are inside the game and not inside the editor. And also we have a safeguard here. So this part of the code only executes if we are inside the game and the unit instance is ready in the scene tree. And what's a bit peculiar about this is that we don't have anything to do with the health bar and the mana bar, but they do need to have access to a unit stats resource, right, to reflect the changes of the unit. So when we duplicate the unit's resource, we could just inject that dependency to both the health bar and the mana bar after we have it. Because they are self-managed pieces of UI, they will connect to the change signal of the unit stats resource on their own. So if we press Ctrl-Alt-O and search for health bar, for example, you'll see that it manages displaying the health on its own. So all we need to do here is add these two lines of code. And if we save it with Ctrl-S, what we changed is these two lines, right, to have the matching types. And for the stats setter function, we injected those dependencies to them. Now, if we save this and play the game, it becomes even worse than it was before, right? Because at least these values look fine, but the tooltip has very little to do with these displayed values here, and everything is just empty. And the reason why is pretty straightforward. It's just we don't reset those values, right? And it's 0 by default. So for example, if we press Ctrl-Alt-O and look for the battle handler, when we set up a battle unit, right, the counter part of the unit, you see we reset the health and the mana when the battle begins. And we would kind of have to do the same thing for the units when they're spawned, so it's not 0 and the progress bars won't be empty. So what we can do is take a look at when we spawn them, just reset those values. And we could try to do that here in the unit class itself, or we can do it when we spawn these units, where we have a bit more control over the life cycle of the unit. Both of these solutions are fine. I did it in the spawner, not in the unit. To me, it makes more sense to do it that way. So if we press Ctrl-Alt-O and search for unit spawner.gd, it's a custom node we have. And we have this spawn unit method, where we use the scene spawner to spawn a new unit and inject the stats as a dependency. And this is where we actually have access to the correct stats for the unit. And since the scene spawner adds it to the scene tree, we couldn't really do it inside the ready callback of the unit, right? Because it would be ready sooner than before the stats get injected. So instead, after just injecting that dependency, we can add two new lines of code. We can just do new unit.stats.reset health, and similarly new unit.stats.reset mana, like so. So these two lines of code here, save it with Ctrl-S, play the game. And now if you buy Robin and Björn, you'll see that the starting mana and starting health values will be reflected on the non-battle units as well. I think it's a nice quality of life improvement. Okay, so this works perfectly fine. We can move on to the next thing. Now we also have a GitHub issue here reported by one of you guys saying that the prepare fight function in the battle handler script hides bench units. Since bench is or should be interactive during battle, this function should only hide the units in the play area. And this is exactly right. So if we go back to the game and play it, you'll see that if I leave on some units on the bench, let's just have one Björn with the gloves and the ring, start the battle, you see that those two Robins disappeared into nothing, but when the game or the battle is concluded, I get my Robins back. And the reason is exactly as our fellow developer suggests. So if we go to the battle handler script and go to our prepare fight method, we just use get3.call group units hide. And this grabs all the units both on the bench and on the game area. And while this is a quick and very elegant solution, it won't do it anymore. There are many ways to fix this. Probably one of those ways would be adding another group to identify the bench units separately from the set of all the units. So we can basically stack groups on scenes, right? But if we scroll all the way up inside the battle handler, we actually have access to the game area's unit grid. And those are the units that we want to hide because we don't want to hide the benched units. So if we make this code a line longer, we can easily fix this by doing something like this. So we grab the game areas unit grid and call the getAllUnits method. This returns an array of units. Loop through all those units and hide them. So this will be potentially a smaller set of units, and this won't touch the benched units at all. So with this one little change here, if we save it and run the game again, now if I have some Robins and Björns, only put Björn in, drag some items on him, and you'll see that those Robins will be there. As well, I can't drag them on the battlefield because we had that logic implemented, but I can still drag them around, buy new Robins and such. You see that this works perfectly fine, but it also introduces a new bug actually to the game. Let me show you what I mean. If I buy a Robin, roll for another Robin, and let's just put one Robin in, right? So we have a Björn and a Robin in our battlefield. Let's buy some XP. So we have 2 Robins together and 1 Björn. Now what happens is if I start a new battle and buy a new Robin, you'll see that even though the unit is hidden, they get combined into a tier 2 Robin mid-battle. And I don't really think this is how it's supposed to work. It doesn't really affect the gameplay, right? Because the Robin that was fighting was still a tier 1, and we successfully get a tier 2 when the battle concludes. So it's not game breaking, but it looks really silly, right? Instead, what would make sense to me is that the unit combiner should be disabled while the game is playing, right? And if we manage to buy units on the bench that would combine into new ones, only do that when the battle has concluded. Now, how do we do that? If we press Ctrl-Alt-O and search for the unit combiner.gd, you'll see that we don't really have any safeguards inside this custom node when it tries to combine units. We have one public method called queueUnitCombinationUpdate, and if we select it and press Ctrl-Shift-F and search for it, you'll see that we use this inside the arena where we glue together the different systems in the project. And what we do is connect the unit spawner's unit spawn signal to queuing a unit combination update. So it does this all the time when we spawn a new unit with the unit spawner, which is fine by default, but we kind of want to filter through this and only actually try to combine units when we are not inside the battle. So let's go back to the unit combiner. Now, there are many ways, again, to approach this. We could do it like in place, so the unit combiner manages itself based on whether we are inside a battle or preparation phase, or we can just provide an API like a Boolean variable, right, which enables and disables the component, and we manage it on a higher level like inside the arena. If you remember, if we press Ctrl-Alt-O and search for GameState.gd, we have a really small resource called GameState, and this can be either preparation or battle. And we have one resource inside the project. If we take a look at GameState in the file system, we have one resource that is changed according to what is currently happening inside the game. So if we press Ctrl-Shift-F and search for GameState and find, you'll see that, for example, in the unit spawner, we have an export variable to this because it behaves differently inside a battle and outside a battle. We have one for the battle handler, and the battle handler is the one where we actually set this. So if we take a look at the battle handler script here and search for the uses of our game state, you'll see that when a battle unit dies, we can check whether the battle has concluded and change the current phase of it. So we have access to a resource project-wide that can always tell us what sort of game state we're currently in and also has a signal when it changes. And we can use this in the unit combiner. I think, at least to me, it makes sense that it can manage this change itself. So that's the fix I'm going to show you here. First of all, we'll need a new export variable to the GameState resource. And we can also include a new member variable, which tracks whether the combiner itself is enabled or not. Since the game usually doesn't start with a battle, we can set it to true by default. Now, inside the ready callback, we can connect to the GameState resources changed signal with our own callback method called onGameStateChanged. Of course, we are yet to implement that method. The only little change we need besides implementing that callback method is here where we start the unit combination update or queue it and start a buffer timer. Instead of starting it right away, we can say that only do this if the unit combiner component itself is enabled. If it's not, then this method essentially does nothing, right? And that's really all there is to it. We just now need to implement that callback method. So if we go all the way down to the bottom of this script, we can do something like this. When the game state changes, we match the current phase. If it's a preparation phase, then we set the enabled property to true because it means that we have concluded a battle. And we also queue a unit combination update to make sure that if we have some extra stacked units on the bench, they will combine after concluding a battle. But if we just started a battle, we just set the enabled property to false to make sure that while the battle is going on, we cannot combine units. And that's really it. If we save this with Ctrl S, we've added this callback method. Inside our public method, we added a safeguard. So we only start the buffer timer if it's currently enabled. We connect it to the game state resources changed signal. We added an export variable for the game state and an enabled flag to keep track of the unit combiner's current state. Now we're not done yet because we have to set this export variable for this thing to work. So let's go back to the Arena 2D view, select our unit combiner, and you see that the game state is empty. So it's really important not to forget to set this. Click on the arrow here, quick load, and gamestate.trs is what we need. Save the whole thing with Ctrl S, play the game again. And now we should be able to play the battle, have an extra Robin on the bench, buy some XP, start the battle, and if I buy another Robin or another one, you know what, I can just keep buying units. And the unit combiner immediately enables itself when the battle is concluded, but not during the battle. And I think, again, this is a nice quality of life change to the project. Awesome. Another issue reported by you guys is that after we changed the shop script to use the scene spawner, when you're running out of gold, all the cards become disabled, even the ones that you could be buying, that you can afford to buy. If there is one card among the 5 that you cannot afford, all the cards become disabled. And this fellow developer here was very nice, also included a video showcasing the bug, but I can show it to you live as well. So if we go ahead and play the game, start buying some XP, maybe even spending some gold to roll down. See, I roll down to 2 gold, and what happens is I cannot afford Arthur, but I could still buy that Robin or that Harry, right? But all of them are disabled. The question is, what the hell is going on here, right? And here's the thing. This is a super weird bug because if we take a look at our shop, Ctrl-Shift-O and search for shop.tscn, if we scroll down, we have a scene spawner that spawns these cards. And that's all we really changed here. If we go to the shop's script, where we roll the units, we use the card spawner spawn scene, right? So this is the only really change we added to the project. Before, what we did is similar to what we changed for the bench items, right? We instantiated it with having a constant in this class and so on. But since we have the scene spawner, why not do it this way? But why does that mean that it will be disabled for all of them? Let's press Ctrl-Alt-O and look for UnitCard.gd to see if we can investigate what's going on here. This is a pretty long class, but what we do have is we have an export variable to the player stats resource. This is super important, right? Because this resource tracks the player's current gold and XP. And here what we care about is the current XP of the player. And we also need access to a unit stats resource, since this is where we know how much the unit costs, right? Now, if we take a look at our ready function, we connect to the player stats changed signal. And we have this method called onPlayerStatsChange, and we also call that method once inside the ready. Now let's see what that method does. Okay, this is cool because it does something that we need to do, right? We check if we have enough gold to buy the thing. If we don't, we set the disabled property to true and also update the modulation of the card. An important thing here is that if we don't have access to a unit stats resource, it doesn't matter that the gold of the player changes, because if we don't have a unit stats next to it as well, we cannot really make this comparison, right? Because we need to know both how much the unit costs and how much gold the player currently has. And if you take a look at the shop, we spawn the card, right? Cast it to a unit card to have auto completion, and on the next line of the code we set the unit stats resource, the unit stats export variable. Okay, then what's the problem here? If we press and hold Control and click on spawn scene, which is the scene spawner's script, what we do is scene.instantiate, right? And parent.addChild, and then return the scene. So essentially the sequence of things happening here is that we instantiate a new card, add it to the container that holds it inside the shop, and return that new thing. And then after we instantiated it and add it under the shop container or card container or whatever the name of this is, then we inject that unit stats dependency. The question here is when the ready callback will be called for this unit card. Because when the ready callback happens, this is where we manually call that function once, right? And evaluate whether we can buy that unit or not. See, the sequence is the following. Let me walk you through this. We instantiate the scene. Then we add it under the shop cards container. And since we add it, it enters the whole node lifecycle of the game. Probably before even returning it from this method, the ready callback of the unit card will be called. And the player stats resource is set even in the inspector, so it will have a player stats resource. We connect to the change signal and call this method once. Now at this point, you can probably guess what happens here. Since we are at this line of code where the cursor is blinking, and this means that we are at this statement, we haven't even set that variable yet, it means that we don't have a unit stats resource since this will be added in the next line of the code, right? So this means that this safeguard turns on and returns from the method even before setting up anything. And that's why we cannot buy those units. So essentially the safeguard works perfectly fine. It's just with adding the scene spawner, we sort of messed up the order of the things happening, right? Because in the old version, this was the place where we injected the unit stats, right? And if we add that unit stats before adding it to the scene tree, then by the time we call it in the ready, this safeguard won't stop this method from executing. Hopefully that makes sense. I think it's an interesting bug fix in a way that it makes you think about the execution of things in Godot, right? So it's not a problem and it's not something that we can't fix easily. It's just I wanted to explain how and why this happens. Basically what we have to do to fix this is after setting the unit stats, just call this method again, which updates the availability of the button, whether we can buy it or not. And to do this, we could do something like new card.onPlayerStats changed. But this looks super weird and quirky because this is a callback method and the private method. That's why we have the leading underscore. This means the leading underscore that you shouldn't call this from the outside, right? And this is outside because we are not inside the unit card class. So one thing I would do before fixing this is renaming that method since we call it in the outside as well. So let's go to unit card. We don't have to change anything with the method itself. I'll just rename it to something like, I don't know, update maybe. And if we rename it and save it, we will mess up the order of the methods because public methods should be above private ones according to the guidelines. So let's just select it, press Ctrl X to cut it and paste it back above unit stats. Setter function. So all I did was move this up and rename it to update. And now we have error messages because we don't have an onPlayerStatsChanged method anymore. And we can just do update like so. In itself, this doesn't solve our problem because in this class, all we did was rename a method and update the references to it. But if we go to the shop, now we can do UnitCard.update once here as well when we spawn it. And all we really need to care about here is that this happens before we call this, right? And that pretty much fixes this bug. So if we save it with Ctrl S and run the game now, buy some XP, start rolling down like crazy. And this is a pretty unfortunate roll because I cannot show you, but if I buy one, I can still show you it works because Harry gets disabled, but all the other ones I can still buy, right? But let's run it again to make sure. Let's buy some more XP maybe. Roll down. Yep, now that's a better example maybe. So we have Arthur's, both of them are disabled, but I can still buy the one cost units. And if I spend all my gold, then all the other ones will be disabled. Okay, so bug fixed. Hopefully it was a great learning experience. And the final GitHub issue that was opened by you guys has to do with the UnitMover. what it says is that when a unit is spawned, it's spawned in the first available location, and when you start dragging a unit, it remembers the starting location but clears it from the unit grid. Which means that if you pick up a unit and you are inside the dragging process, if you have any means of spawning a new unit while a drag is happening, it will occupy the same spot that where you started the dragging from, and then if you cancel the dragging, you have two units on the same grid space. This person also says that in theory this is somewhat fixed by being unable to drag a unit and purchase a unit at the same time, but if there was a system that could spawn you a new unit when you are dragging, then this would be a pretty nasty bug. And this is true, so I think it's worth fixing, even though it doesn't really affect the gameplay in the current state of the game. Let me first show you the bug in action so you understand better what's going on. And to do that, first we need to provide a way to spawn new units while dragging a unit. So let's press Ctrl-Alt-O and search for unitspawner.gd. Right click on it and close all the other tabs to keep things tidy. And if we scroll all the way up, what we can do is we can override the input callback and say that if we press the test1 button or action, which is Q in my case, we just spawn a unit, but we need to say which unit we spawn. So what we can do is we can search for Bjorn, for example, and just drag him inside the parentheses by pressing and holding Control. So we have the resource preloaded. Save it, play the game, and now I can actually show you the bug. So let's buy a Robin and a Bjorn, maybe another Robin. And if I start dragging that Robin, right, I'm still in the middle of the dragging process. If I press Q, you see a Bjorn gets spawned in the same place. And if I cancel the dragging now, I have this error where I have two units in the same position. And this shouldn't be possible in the game because it messes up the unit grid, right? Because the unit grid can only store one unit at the same location. But if I do that, everything else works fine. So the new units will be spawned in different positions, but it still is considered an empty place when I start the dragging. And since it can happen that I cancel the dragging and move back to the same position, this is super risky. So that's the bug we currently have and the one we need to fix. Now let's see what's actually moving a unit like, because it's been a while since we did the custom node, right? So press Ctrl-Alt-O and search for UnitMover.gd. And this is where the magic happens. And if we scroll all the way up, what matters here is when we set up a new unit, we connect to the drag and drop components methods. We have drag started, drag canceled, and dropped, right? So those are the ones that we need to take a look at. If you scroll down, we have set highlighters, which enables or disables tile highlighter components. We have get play area for position. It doesn't really matter here. We also have reset unit to starting position. Now, this is interesting because what we do here is unit.reset after dragging, which will snap the unit back to its starting position. But we also re-add it to the unit grid. And the reason why we need to do this is because when we start moving or dragging a unit, at onUnitDragStarted, you see what we do is we immediately remove the unit from the unit grid. And this is what's causing the problem. As soon as we start dragging a unit, we remove it from the grid. And so when we reset the unit to its starting position, we need to re-add it, right? Because we removed it when we started the dragging. Also, when we move the unit to a new position, we add it to the unit grid, which is fine. And we also reparent it to the unit grid that the unit will reside in. That's also fine. And when the drag is cancelled, we set the highlighters to false and reset the unit to its starting position, which will then in turn, again, re-add it to the unit grid where the dragging process started from. Now, the most complicated part is when the unit is dropped somewhere, because it can happen that it was an invalid drop, or we did the drag and drop from the bench to the game, and we are inside battling, right? So in both of these cases, we need to reset the unit. Again, calling this right now means that we re-add it to the unit grid as well. Then we grab all the references and swap the units if we need them to, because we need to consider whether we are doing a swap or just moving the unit to an empty space. And finally, we move the unit. So this is a bit of a complicated logic. It was a pretty difficult episode back then, but hopefully you remember all the different parts that are needed to do this. And we need to re-examine how we do this. So for example, when we reset the unit to its starting position, we don't really want to re-add the unit to the unit grid, because the new way how we want this to work is that we don't necessarily remove the unit at the moment we start dragging. We only need to remove the old position of the unit from the unit grid if it was a successful drag, right? which means that either we swapped place with another unit or we moved the unit to an empty space. Only in these cases, when the actual moving of the unit is done, is where we want to remove the old position, which actually simplifies the system a lot, surprisingly. So when the drag starts, we actually don't want to do any of that stuff, because all these lines have to do with removing the unit from its original unit grid. And we don't want to do that anymore. So we can delete all of this, which in turn means that when we start dragging a unit, the only really thing we want to do is to set the tile highlighters to true. We don't even need the unit as a parameter. And if that callback method is just one line of code, then we can actually get rid of it and we can just connect to that line of code, right? So the first thing we can do is we can get rid of this whole onUnitDragStarted method actually. So let's grab the set highlighters true, copy it or cut it with Ctrl X, and let's remove this line here. But right now we'll have an error message saying that we have no such callback method like this. But when the drag starts, what we actually want to do is set highlighters, but we can't just call true like this, since this is a callable connection, but we can do set highlighters.bind and say that we call it with this true argument. So when the drag starts, we only want to enable all the tile highlighters inside the game. That's cool because it actually makes the code easier. See, the problem is right now that we changed that drag started mechanic, actually it won't be removed at all from the old position. But we'll solve that in a second. Also, what this means, if we want to reset the unit to its starting position, since it wasn't removed in the first place when it was an unsuccessful drop, we actually don't have to re-edit to its old position. So all the lines of code that we use for re-editing it to its old position can be deleted as well. So this is where we re-edit to its old position. When resetting the position, we can delete this, which means that this tile variable is unused. This is why we have this warning message. Yeah, unused variable, so we can get rid of this as well safely. And then I believe that the I itself will be an unused variable. We can delete that as well. So this reset becomes a much easier method as well when we reset it to its starting position. Again, the reason why we don't need to re-edit is because we just don't remove it in the first place when we start dragging. We only remove the unit's old position when there was an actual successful drop. But this is what we still need to change. So we need to go to our unit dropped method, right? Because this is where we handle dropping the unit. Now we set the highlighters to false when this happens and grab all these variables that help us decide what actually happened with this drop. We have the old and the drop area indices. We have the information if it was an invalid drop or not. And we know if we went from bench to game or not, right? So if it was an invalid drop or bench to game and the game is battling, we reset the unit to its starting position and we don't actually have to do anything in this case in terms of managing the unit grids because we didn't remove it when we started dragging. So it will not just snap back to its original position, but since we also kept the unit grid reference at that coordinate, we're fine. And this does an early return, so everything after this will be only executed when it was a successful drop. And that can happen in two different cases. Either we swapped two units with each other, or we just moved the unit to its new place, which was empty. And it doesn't really matter to us which one happened here. We have 4 other member variables at this point of the code, which is super cool because we have access to the old area and the old tile where we started the dragging from, and to the new area and the new tile where we want to put the unit to. So what we need to do is actually one line of code here. At this point, we can for sure say that it was a successful drop, and this is the only place where we say that we removed the unit from its old tile. And this solves our problem, because if we are still hanging inside the dragging process, we never really reach that code, because this line of code will only be reached if we drop the unit and it was a valid drop somewhere. All the other cases, we don't remove the old unit grids entry, so it still counts as occupied. And we have to do this here because if we do a swap, we need to move the unit that we're swapping with to the original position where we had our unit. And to do this on our unit grid, we need that slot to be empty by that time. So we remove the unit first. And also, if we don't do any swaps, we can disregard the part of the code that handles swapping. And then again, what we need to do is remove the unit from its old position and move the unit to its new position, right? Hopefully that makes sense. I know it's a bit harder to wrap your head around it, but hopefully you understand the logic behind this. And actually, I think what's cool about this bug is that it simplifies, I think, the logic and the solution for this UnitMover script. We ended up with fewer lines of code than we started with, so it's pretty cool. And I think we should be good to go, but to test this, it's not enough to just test this on feeling, I think. We should just add some sort of code to make sure it's easy to see if it works properly or not, right? And to do this, let's just use the unit grids. So press Ctrl+O and search for unitgrid.gd. And inside the ready callback, we have a signal when the unit grid changes. So we can just do something like unitgridChange.connect and do an anonymous function where we loop through all our units. First, we just print the name of the node so we know if it's printing out the arena grid or the bench. After that, we can just loop through our units inside the dictionary that we use to keep track of all the units. And we can just do if units unit. So if it's not a null value, we print out both the key, so we know the position, and both the unit that is residing at that coordinate. Because if you remember, this is a dictionary where the keys are coordinates and the values are the unit instances themselves. So this will need to be printed next to each other, the coordinate and the unit. And I use print t here, which puts a tab between the two values that we print out. And I use simple print here to print the name of it. So now if we save this, this will make it much easier to debug if it is working in the intended way. So let's just say that, okay, now the output is empty. I know that the game window will be smaller in this case, but we don't really care about this. We want to make sure that it works the way we expect it to. So let's buy a Robin, a Björn, and another Robin. And you'll see that the spawning is fine. We have 0, 0, 1, 0, and 2, 0, and we have 3 units, right? Now, in the old system, if I were to start dragging that Robin, I should have another output message because starting the dragging immediately changes the unit grid. But right now you see that there's no message. So the 0, 0 coordinate is still handled as occupied. So now if I press Q and spawn a new Björn, you see the bench unit grid still has that Robin I'm dragging at 0, 0, which means that I can no longer spawn 2 units at the same place. And I can actually swap units around. So if I swap this Robin with the Björn, you'll see it correctly handles it because this Robin was called a unit and all the other ones have these instantiated names with the ats. It correctly represents the current state of the game. Now, if I drag this Robin to the game area at this position, you'll see that the bench grid becomes smaller and the arena unit grid becomes occupied. So I can do all sorts of stuff now if I start dragging that Björn. Let's see if swapping still works. So I swap those two. And the final version that I have will be Robin, Björn, an instantiated Robin, and I have the Björn at that position. And you see it has more. Let me clear it up actually, so you'll see it better. So when I swap the 2 units, you'll see I have multiple messages because they change multiple times. So first, from the bench, the Robin was removed, and from the arena, the Björn was removed. And then we re-add both of them at their new positions. So the bench becomes this version, and the arena becomes this version. So everything is working as intended. I can still do stuff like selecting Björn, dragging them around, pressing Q to spawn a new one, and you see they combine just as well. Now if I press Q, it spawns at the first position. If I drag it, press Q, spawns in a new position. I can swap units around. So everything still works as expected. The unit combiner spawning new units. So I would say that this was a pretty successful fix. Now, of course, if we are sure that it's fixed, we can delete all the debugging code. But actually, at the end of the episode, I want to clean up the whole project, so we can leave it as is for now. And that concludes fixing all the GitHub issues that we had and all the other issues I can find. Now we just have those 2 very peculiar bugs I was talking about. If you like my content, please consider checking out my Ko-fi page where you can donate one time or become a member and get early access to all my content and videos. And for showing the first bug, it's actually pretty hard to trigger it. So this was an email sent to me by one of my viewers. And they were very cool because sometimes I've kind of run into the same bug, but it was really hard to tell what's triggering it, or I would say it's hard to manually trigger it. And this person just said to me a pretty sure way to trigger that bug and also send me the project as well. So let me show you with that project. So actually you can see that the project looks slightly different to what we do in the course. So this is not the project that we are currently editing, but this will be cool so I can show it to you. So right now you don't have to do anything, just lay back and watch, right? So let's play the game. And we spawn 3 Bjorns, right? So if I put them in positions right here, and right here, there is a big chance to an error to occur. So if I go to the debugger, we can clear it out with warnings, but the output window is empty for now. So let's just go ahead and start the battle. Okay, and it did happen. The bug did happen. So what happens is, ignore the output messages for now. I added those in. But if we go to the debugger, we have this really weird error message saying that error calling from signal target reached to callable node UnitAI.gd on chase state target reached cannot convert argument 1 from object to object. Now this is a super weird error message, right? But at least we have a script and a method name given. So if we press Ctrl-Alt-O and search for UnitAI in the other project, this is the line where we trigger that error message. And it doesn't always happen, but sometimes it does. And it has to do with the argument, which is this, right? The target. And it says it cannot convert it from object to object. Okay, I guess. So when do we reach this part of the code? Well, if we scroll up and we start chasing the units, we have this chase state.targetReached.connect, right? So when we reach a target, we connect to this callback method and execute this auto attack state transition. So if we go to the chase state, we have the target reach signal. Where do we emit it? So if I press Ctrl F and search for it, we have the end chase method. You don't have this print here. I just added this to debug the whole thing. What we do is we, at the end of the frame, emit the target reach signal and grab the target finder's targets in range array's first element. Now, what happens here is we use call deferred, so we wait to the end of the frame for this to happen in hopes that we don't add invalid targets to the game. Because it might happen that the target I reached is being deleted with Q3 because it just died, right? That's why we use call deferred here. And what happens if we go to the output, this is what gets passed in the signal, right? The target finder's targets in ranged array's first element. That if I press and hold Control and click on this, it's an array of battle units. We have this target finder component on the battle unit. And what happens is it's most of the time an area 2D with a legit ID, so it's a valid target for the next auto attack, right? But sometimes we get this freed object instead. So what happens is if we rerun the game now and hopefully trigger the error again, I know it's real fast, but maybe in editing I'll slow it down for you. So sometimes when the error actually triggers, it triggered again, is because Bjorn swings and the auto attack damages 2 enemies at once, and both of those enemies will be deleted by the end of the frame. And either that Bjorn or another Bjorn wants to target one of those units, right? Because there are not many enemies, both of those get deleted, and it might happen that one of the units try to chase that or attack that as a target. So because in the same frame 2 enemies die, it cannot auto attack the other one because it will be a freed object as well. And the error message occurs because it is called a freed object, which means that the array at the target finder has a lingering reference to it, but it's not a valid object inside the game anymore. And you try to convert a quasi null value to a battle unit. And this is what triggers this error message. And kind of that's the thing that you need to be aware of when you store an array of references, that at all times they need to be kept up to date. Because we have this find target thing that updates all the methods here. When it accesses the signals, we actually erase it from the array, which is fine. It's just that sometimes we have that lingering reference because it might happen sooner that we want to auto attack the other one before it even gets deleted from the array. So that's a really tricky bug, and why it's not game breaking, I think it's worth fixing despite that. And I think our chase state is a bit oddly constructed in a way, because we have this end chase method that concludes the chasing when we have a target in range, right? But actually this will be called not at the end of the frame because we don't use call deferred. So if we search for end chase calls inside the script, right, it's never called with call deferred. So it won't be called at the end of the frame. But what we do is we emit the signal at the end of the frame. And this creates that discrepancy because it might happen that when we called it, we still had the valid target, But when we actually emitted the signal, the time that elapsed between the two is where the unit was deleted, right? So what I would do to future-proof this, and you can make all these changes in your project as well, even if the code looks slightly different because it's not my project. The changes we make here can be transitioned into the other project as well. So now you can start following along. At each and every call of end chase, when we want to see if we have a target in range, instead of just straight up calling it, we just call it at the end of the frame instead with call deferred, okay? So we have to do it in all places where we have end chase. So searching for it and moving to the next one helps a lot here. Make sure that everything remains tidy, so replace it here, replace it here. Here we don't replace it because that's just a function declaration. And we have this one at the bottom. Replace it here as well. So if you replace it at all places, we only have one match for the search, which is the function definition itself. Now, this print statement, you don't have to edit. I just added it to check if we have those freed object outputs. But here we need to do a bit more mindful of emitting that signal. We can still print out that target if we wanted to, but what I also wanted to do is actually store this inside a variable because we'll use it in multiple places now. So we can just do var target colon equals, and we store that variable. And what we do is we check if it's valid. So if is instance valid target, and this will be false if at the end of the frame it's a freed object. It's something that is being deleted, right? This whole method, remember, will be called at the end of the frame because we use call deferred everywhere. So we can just say that we only emit the target reach signal if at the end of the frame this is still a valid target. And right now we don't have to use call deferred with emit. We can just delete that because it's already called at the end of the frame, this whole function. And instead of redundancy, we can just use target here as well. And also if it's not a valid target, so it might happen that at the end of the frame we wanted to end the chase, but the target we wanted to try to reach is not a valid target anymore. Then we actually don't want to emit the target reach signal. We can do two things here. We can either emit a stuck signal, so we go to a stuck state and saying that, okay, we had a target, but it's kind of not there anymore. Or we can say that it's unnecessary to move to the stuck state and we can just restart the chase, right? In my reference project, I went to the stuck state, but I think both works fine. I just stick to that solution. It very rarely happens, but if that's the case, we can get stuck for a bit and then go to chasing again. And if we print that target before emitting the signal to see if our solution is working or not, since we have that if guard statement here, it shouldn't ever happen that we print out freed object here now, and the error message should disappear. So we should no longer trigger this onChase target reached thing. So again, we changed a bunch inside this method, and all of these calls that call this onChase method were modified to be call deferred to make sure that the method itself is called at the end of the frame. If we save this with Control S and play again, it's not my project, but it will work the same for you. Occupy those positions, start a battle. And it doesn't always trigger even at this position, but if you take a look at the output, I don't have any freed objects here. And just to make sure I can run it a couple of times, because like running 5 or 6 times always triggered that error message inside this position pretty consistently. So no matter how many times I run it, it's like the 3rd or 4th time, it's still no error message. So it looks like we made it safer to only pick actually valid targets inside the game. And no matter how many times I run it, just 1 or 2 more times to be sure, but no error message, and only print out valid area 2Ds as targets. Yep, 1 more time just to be 100%. Yep. So it's a bit weird and tricky to fix thing, especially because at the end state of the project, it was really hard to trigger this consistently because all the other stuff like modifiers, modified health values, damages, it was harder to like execute multiple enemies at once in the same frame. So thanks for Aaron for sending me his project because it made it much easier to fix. And I just wanted to show you that in this project where we explicitly and kind of reliably could trigger that error, it disappears. So the fix is fine. Okay, so one weird bug down. Now we have just the last thing to do, and we can hop back to the original project now because I can confidently trigger that one in mine as well. And the final thing that wraps up this whole project is actually a memory leak that we have inside the game, funnily enough. So if we go back to 2D view, close all the things that are not the arena, and start playing the game, let's go to debugger, monitors, and let's click on objects and nodes. So with this little trick here, you can monitor how many objects and nodes you have inside your game. First, we establish a baseline. So let's start a new battle, buy some robins, maybe find a Bjorn as well. So you'll see when I buy units, spawn them, there's a spike in both nodes and objects, which is fine because I just bring in new things to the game. Let's drag them inside, buy some XP, and let's take a look. So the game, let's, just show the memory usage as well, and maybe we can do resources too. So that's the baseline we have. We use almost 70 megabytes of RAM. We have 249 resources, 289 nodes, and 2,368 objects. If I start a battle, the numbers bump up a bunch, right? Which is absolutely fine. I found in all the zombies, the abilities, the debugging things and all that. Now, if we conclude the battle, you'll see that we crossed the threshold of 70 megabytes of RAM. And you'll see that the nodes actually went back to the same number, that 289. So that's fine because we don't have any nodes that are lingering there. And that's cool because there might be projectiles, leaving the whole game screen or abilities. But we actually took care of deleting them consistently. But that's not the case for objects. You'll see that it's a bit higher than the baseline that we started with. So now we have 2,394. And if we start a battle again, it climbs up during battle, but that's to be expected, Still the same for resources. Nodes bump up a bunch and the memory gets increased a bit. And when we conclude the game, nodes go back to the same number, but objects don't really, you see? Now we have 2,400. So if we start another battle, let's wait for the battle to conclude. And again, it becomes just a tiny bit more, right? And I would say that realistically speaking, it's not an issue. Like the game uses 70 megabytes of RAM. So I think you would have to do tens of thousands of battles during one playthrough of the game for it to become an issue. And if your problem with your game is that players play 1,000,000 times before closing the game, then you're probably good to go, right? Because you're already doing very well from selling your game or making people to become addicted to it. So it's like 400s of megabytes of RAM increase with each battle or something like that. But you see that the baseline is slowly climbing up while the nodes are consistent, right? We don't have any lingering nodes. And actually we have an orphan node stick for that as well, and it sits at 0. So we don't really have a problem with nodes, but we do really have a problem with objects. And to me, this was really tricky to debug for the first time. But you'll see that it's slowly but surely climbing up. Now, how on earth do we test this? If we press F1 and search for object, this is the base class for all the other classes in the engine. Object is the lowest that we can go. We don't really use objects in the game at all. So it's not something that we have control over, but we do use object-derived classes. We have basically 3. We have RefCounted, we have resource, and we have node. Now we know that nodes are not a problem, right? Because, we saw that nodes always stick to the same number, and resources are kind of stored inside the game, so they are harder to leak. It's a good guess that it has to do something with the RefCounted class. The Shaggy Dev has a really good video on it explaining how and when you can create memory leaks. So first of all, I recommend watching that video if you're interested. But we'll try to see here through a practical example what this means and how we can fix it. If we press Ctrl-Shift-F and search for RefCounted, we can see how many RefCounted classes we have inside the game, and it's not that much. We have the modifier, we have the finite state machine, and we have the state. When RefCounted classes become a memory leak is when they have circular references. What does this mean? Using RefCounted itself doesn't mean that you have to have a memory leak, because basically what it does for you is that it keeps track of a reference count, how many other classes refer to that RefCounted instance. And if it's greater than or equal to 1, it means that it needs to be kept alive because there is a reference to it somewhere. But if there are no reference to it, if the reference counter goes to 0, it can be automatically released. But here's the catch, right? RefCounted instances caught in a cyclic reference will not be freed automatically. if a node holds to a reference to an instance A, which directly or indirectly holds a reference back to A, A's reference count will be 2. So we have this circular reference thing where one node reference is RefCounted and the RefCounted reference is the node. So they always have this tight reference to each other, creating a cyclic dependency, right? And the docs say that you can prevent this if one of the references that you create will be a weak reference, right? So if we click on that weak reference, it says it returns a weak ref instance holding a weak reference to object. A weak reference to an object is not enough to keep the object alive. When the only remaining references are weak, then it can be freed from the memory. Okay, so it probably has to do something with this. Now, how do we confirm this, first of all? Well, we have 3 RefCounted classes, and we need to kind of examine where we might have a cyclic dependency or a cyclic reference. Let's just keep this doc page here, so close the other tabs. And if we go to the search results, we already searched for it, right? So we have the modifier. Now let's take a look at the modifier. It extends the RefCounted class. It has a signal that it's changed. And we need to look for variables that are not modifiers and that might have references back to the modifiers. So type definitely doesn't because it's just an enum inside the same class. We have an array of modifier values. Okay, that might be something. And that's pretty much it because all the other ones are just methods. Now, if we press and hold Control and click on modifier values, these are resources, right? So here what we need to look for is if we have modifier anywhere, right? Directly or indirectly. Because if we do, it means that we have a cyclic reference, right? Because modifier references the modifier value class, and then the modifier value class would reference the modifier class. But actually that's not the case because we have an enum here as well, and we just have a value for that enum, float, int, strings. These are all very basic data types, right? So here we can confidently say that there is no cyclic reference between them because they don't even reference each other. It's just a one-way reference from modifier to modifier value. So this doesn't seem like a likely culprit here. Let's take a look at the finite state machine then, because we have state and finite state machine, and those two are kind of related to each other. So let's go to the finite state machine. This is RefCounted again, and we really have a reference to a state. Okay, so let's look at the state then, press and hold Control and click on it. Now this doesn't have reference to a finite state machine, right? So it seems like there's no cyclic dependency or reference here either. But here is where it gets a bit tricky because this class has a reference to an actor, which is just set to be a node here, but we know for sure that inside our game where we actually have states, this is a very bare bones state implementation, right? If we close the other tabs and look for a real state like the auto attack state, we know that we almost immediately when we enter the state convert to this actor to a battle unit because we know for sure that we use this finite state machine. For example, for the battle units, AI management. Now this is a bit more interesting and it's a bit more suspicious as well because battle units, if we press and hold Control and click on them, have a unit AI. Again, if we press and hold Control and click on that, unit AI does have a finite state machine, which does have a current state. So we could say that indirectly, in a very long chain of events, this might be a cyclic reference, right? Because I keep a reference to an actor unit, which is a battle unit. It has a unit AI, which has a finite state machine, which has a state. And that current state can be the auto attack state. I hope this is not too mind-boggling at once, but this might be considered a cyclic dependency, so it's worth checking if we have this leak or not. All the other ones seem very unlikely. What's the easiest way to check this? Well, we can just add some debugging code, right? So if we go to state.gd, we can say that all states can be counted and we can see how many we have while the game is running. We can do that with static variables because static variables are class-wide. They are not tied to one specific state. So we can do something like this. We'll add a new static variable called instance count and make it equal to 0 when the game runs. And inside the init method, when we actually create a new state, we can increase that counter by 1. But also when we delete a state from memory, because the reference counter goes to 0, we should print that out as well. So we can see how it changes, right? Let's include a print statement as well. And we say that self is created and self will print out, the identifier of that current state. We can also print the current counter for the state count. Now for the deletion of RefCounted, we have the notification system in Godot. So if we press F1 and search for _notification, you'll see that this will be called, this is a built-in virtual method, which will be called when the object receives a notification. And it says that the base object defines a few notifications, post-initialize and pre-delete. Pre-delete sounds kind of fine here, so let's click on pre-delete here. And it says that notification received when the object is about to be deleted can be used like destructors. Now this is exactly what we want here, because we want to subtract one from that counter, from that static counter when one state will be deleted from the memory. So let's just override that virtual method, and this what will be an enum value, right? That identifies the notification. So we can do, if it's pre-delete, then we subtract one from the counter and print it out as well. Now let's save this with Control S and see if it helps us identifying that memory leak. Let's add in the Robin and the Björn, add some XP, and so far we shouldn't have any debug messages. We still have the unit grid, which is a bit annoying. Maybe we can delete that in a second, but let's just clear it for now. And so far, no output messages because we only use states when the battle begins. So when we start switching between the different states and doing the battle, that's when we should have a bunch of messages here. Oh, and we do. Also, the grid changes constantly, so it's kind of hard to tell what's going on. So I think we should delete that print message before investigating this issue. So let's go back to the unit grid script and just change this line, right? This is what we use to check if the new UnitMover bug fix works or not. Let's just get rid of that, save it, and rerun the game. It might be a bit easier. Okay, so let's see the output window now. It should be pretty empty. Buy some XP, start the game. Okay, now this is better. So we have this total counter, and you see it goes up and down constantly. And if everything works fine, this should go back to 0 when we finish the battle, right? Because all the state objects that are connected to battle units should be deleted because there should be no reference to them. But what's really strange here is that it actually goes to the negatives. Does that mean that we actually save memory and the leak is fixed? Well, absolutely not. But what this means is that the logic is somehow not working fine to keep track of these references. But it does seem fine, right? When we call the init, this is sort of like the constructor when the state is created, and this is called when the state is deleted. So how on earth do we get negative numbers? Now here what we need to do is actually take a look at all the states that we have in the game. So we have the auto attack state open, we need the chase state, we also need the cast state, and we also need the stuck state. I believe those are the 4 states that we have, and the thing is they all extend the state class, right? And this has to do how inheritance works in object-oriented programming languages. When you override that init method, and we don't here, so this cannot be a problem. For the auto attack state, we do override the init method. For the cast, I think we don't. We have enter, exit, and the callback. And for the chase, we have enter, exit, callback, and a bunch of other ones. So what happens is we override that for the auto attack state, because to transition into that state, we don't just need the actor itself, we need the target as well. So what we did is we overrode the init that we have defined inside the state, which is not a problem on its own, but what it means is that this won't be executed at all. So the problem is when we go to an auto attack state, the state counter won't increment, and that's why, or that's how we end up with negative values. So what we can do to fix this is to actually make sure that we code this as well, right? And the way to do this is delete this, where we set the actor to the new actor, because this is done anyways, right? Inside the original init class. And this is called super. So if we call super and pass in the new actor, what this will do, if I press and hold Control and click on it, it jumps into that other init method inside the state class, which the auto attack state originates from, indicating that this is the method that will be called. This is very specific to object-oriented languages, and we wouldn't have to deal with this at all for the game. We just kind of need this for the debugging to work in this case. So if we have this change and run the game again, we shouldn't have negative values anymore. Buy some units, put them in, buy some XP, and start the game. Now let's see the output window now. We have some values subtracted, added, and changing. And these are definitely not negative. Okay, so we have super weird messages. When we delete one, it says object null. But when we add one, we have the correct instance ID. But I guess we found a leak. Because this number should go down to 0, right? When a battle concludes. And the thing is, it doesn't. It stays at 9. So if I clear the console for now and start an auto battle, it starts from 9, this counter, right? So when I create all these new classes, these state instances, the number just goes up and up and up. And somehow those references to the older states from the previous battle are still kept in the memory, hence causing the memory leak in the game. So now we have 20. At least we confirmed that there is a memory leak. We confirmed that it is caused by the state RefCounted class, but the problem is we don't know which one. It's definitely not caused by this class, right? Because this is just a bare bones state that we don't really use at all. It has to do one of these 4 or even multiple of them, right? So the next logical step would be to kind of identify which states get stuck in the memory when a battle concludes. So this is what we need to do next. And I find that the easiest way to do this is to store the ID, the instance ID of all the states that we create inside an array. And when a battle concludes, loop through them and dump all the still present states either to the console window or to a file, which we can scroll through in our game. So to do that, we don't really need that instance count anymore. This was just to kind of confirm what we knew, right? So we can delete these lines of code now. We don't need the notification either anymore. And instead of the instance count, we'll just add another static variable. And this will be an array of instance IDs. So what we do is when a state gets added with the init, we can just do objects.append and use self.getInstanceID. If we press and hold Control, this returns the object's unique instance ID. And can be used to retrieve this object with global scope.instance from ID. And this is what we'll do in the battle handler. So the logic that we do here is that for each initialized state that was created in a game, we save the instance ID in an array so we can see at the end of the battle which states are still living or being stuck. Because in theory, all of them should be deleted. So by the time the battle is concluded, there should be no states where the instance IDs are still valid. And if there are ones, these are the ones that are being stuck. So let's save this with Control S and open our battle handler because that's where we can conclude a battle. We even have a method called cleanup fight, right? When we clean up the fight, just to be sure that everything is processed when we end the battle, I just waited 3 frames here, which is an arbitrary number. I think 1 frame would be enough, but just to be sure, I waited more. Or we can even create a timer, which is, I guess, even more safe. So we can do get_create timer, wait 1 second. And wait the timeout signal. 1 second should be more than enough to get rid of all the states after concluding a battle. What we can do is we can just say print and print out all the states that are lingering there. Just do a nice little print here. Iterate through all the instance IDs that we have in that static variable, right? And try to grab the object with this instance from ID method that was mentioned in the docs, right? So it returns an object that corresponds to that instance ID because all objects in Godot have a unique ID and we saved them in that array. If it is still a valid reference that we can grab, which shouldn't be the case, it means that we have a leaked state, right? Because after 1 second, when a battle is cleaned up, all the IDs that we have inside that array should be invalid by that time. So if we have one that isn't, let's just print it out in a meaningful way. I know it's a bit of a longer line. What we do is we print out the ID, we print out the script with object.getScript.getPath, which will help us identify which state we are talking about, right? Because it will either end with auto attack state, cast state, chase state, or stuck state. And also get a reference count because, RefCounted classes, we can be sure if it's greater than or equal to 2, it means that we have a circular reference somewhere. Because if it's just 1 or 0, it means that it was already deleted. So if we save this with Ctrl S and play the game now, we should be able to identify finally what's causing the memory leak. Let's just buy some XP, play the game. And we don't have output anymore during the battle because we need to conclude it and wait 1 second to get anything. And we had like 9 or 10 lingering objects when we had the counter, and it kind of corresponds to what we have here. See, we have, I don't know how many, but it's like 9 or 10, and all of them come from the chase state, and the reference count is 2, which is a really telling sign that we have some sort of a cyclic reference keeping those states alive. Whew, okay, now this means that at least we have some starting point to find and stop that leak. We can keep this in to make sure that we can test it, whether we fix the leak completely or not, because if we can reach a point where we just only print this, it means that we have no leaks and we can check the numbers again. Now the question is, what's causing that leak inside the chase state? Because one kind of idea that we had is that it has to do with this casting actor as a battle unit, right? We said that it might be causing this circular reference because the battle unit indirectly, in a very long chain, has access to the finite state machine. The reason why we can rule this out is because then we would have lingering auto attack states as well, right? And we don't. We haven't seen any. I cleared the output, but we haven't seen any auto attack states or casting states lingering. We only had problem with the chase state. So I think we can safely rule out that this conversion of reference is the culprit. Now, what else can be the problem? One thing that can be suspicious in these cases as well is that we have a signal connection that doesn't break. But I don't think that's the case either, because when we enter this state, we connect to this signal. But when we exit the state, we also disconnect. So this is safe in this way. What else do we have here? We have a tween. We have the actor unit and the tween. What do we do with this tween? If we search for the tween, we have this safeguard here that when we chase and the tween is already running, we return. Now this is where we actually do something with the tween. We create a reference and we use the actor unit that create tween. Now to create tweens, you have multiple ways to do that. If we press and hold Control and click on it, it says that creates a new tween and binds it to a node. This is the equivalent of doing getTree.createTween.bind node. So what is binding doing for us in this case? Well, we can click on it and see what it does. So let's click on tween.bind node. And it says it binds this tween with the given node. Tweens are processed directly by the scene tree, so they run independently of the animated nodes. When you bind the node with the tween will hold the animation when the object is not inside the tree, and the tween will be automatically killed when the bound object is freed. Okay, this is a good use case for us and it makes a lot of sense, because if we go back to our chase state here, we bind it to the actor unit, so if it gets killed, we don't really want this tween to linger around and try to play animations and try to find targets and such. So in this case, it makes a lot of sense to bind this tween to the unit. And the problem might happen when we actually have this tween and it didn't finish and we change to a new state. So what do we do then, right? Because when we exit the state, we only disconnect from the signal, but it might happen that we are moving on to a different state in the game, and we still have that reference to the tween. So what we didn't do, and what we might want to do, is when we actually exit the state, and if for whatever reason this tween is still alive, we can kill it, to make sure that the actor unit doesn't have a reference to it, because this can create a cyclic reference. How? The tween itself is a new object created inside the memory, right? And tween itself, if we scroll up, is a RefCounted object. So the tween itself will have a reference to that actor unit, and the actor unit has a reference to that tween. So this tween will be kept alive despite the fact that we exited this state and we don't want to do anything with it. We actually kill it when the tween is finished, but it takes time to finish because we move the actor unit one tile, right? So one guess or thing we can try is to say when we exit the state, for whatever reason, if the tween is still running, we just kill it. And this makes sure that we don't have any lingering reference to it. So if we can check if the tween is still alive, and we can do tween.kill, and also just to make sure that we don't have any reference to it, we can set this member variable to null as well, which for sure nullifies all the references that we have to that tween, so the tween won't live on in the memory as well. Now, this change, if we save it, we can test it, right? Whether it helps anything or not. Let's play the game, add some units in. And we had like 9 or 10 changes, right? Or 9 or 10 messages when the battle was concluded. So let's see if it does anything to it. Oh, it went down, right? So we don't have like 9 or 10, but we still have 4, and it still comes from the chase state, but it's much better than it was before. If we play the game again, it's not just a one-time thing either. So if another battle concludes, wait a second, Okay, now we have a bit more. But let's not forget that we already had 4 to begin with, so the first 4 are those ones, and we have 4 other lingering references. So this actually helped a lot because we have fewer leaks. So this addition helped us to alleviate some of those tween-related things. Now, another interesting thing is if we scroll all the way down here. So when the tween is finished, we execute an anonymous function, right? We use tween.kill and call a bunch of methods that are inside the chase state. And this can be a bit problematic as well because of the way how anonymous functions work. However, if you take a look at the documentation for Lambda functions or anonymous functions, it says that if we scroll down, we use the outside context, right, that is available inside the class. And it says that Lambda functions capture the local environment. So if we have a variable that is outside the anonymous function, I can still print that X variable. And it says that local variables are captured by value once when the Lambda is created. Also, the Lambda cannot reassign local variables. Okay, that doesn't really matter to us. But the problem is, and this is getting very technical now, the problem is when we reach to that anonymous function in the code, right? We capture the local environment. And when the tween is finished, the tween itself is still alive. So it doesn't really matter that we kill it. The tween is still alive and we save that local environment that we have for that Lambda. So we have access to all these member variables that we created above the Lambda and also can call functions like hasTargetInRange, which is defined in the same class. So all these references are kind of saved inside this Lambda, which weirdly enough creates this circular reference as well, because it has a snapshot of the tween reference, it has a snapshot of all these callables that we have here, and it might happen that these are kept alive and keep referencing each other with that callable. To test this, what we can do is we can just select this whole anonymous function, cut it with Ctrl X, and we can do something like onTween finished, and we just create a new callback method for this at the very bottom of the script. Right now we have the error message, but if we scroll all the way down and just repaste the whole thing, clean up the indentation and provide a name, we call this onTween finished, and of course return a void value from it. Now this seems a bit of a weird change because we essentially do the same thing, and I kind of like how the anonymous function read better. But if we play the game now, we can see if it actually makes a change or not. And if we buy some XP, play the battle, let's add some items. Okay, the battle concludes. We wait a second and see. No leak states. I know this is really technical and it took me ages to figure it out, but hopefully the whole process was useful for you. So actually, you need to be very careful with creating those tweens and binding them inside the RefCounted class because they might create these kept alive circular references or cyclic references. So just moving that anonymous function to its own method avoided creating that Lambda context that was needed to execute that function, and we got rid of those cyclic dependencies. So it had to do with the tweening actually, which was kind of a telling sign because no other states had an issue. So now if we play the game again, we shouldn't have any leaks. And we can check those reference counters and object counters again in the debugging panel. So let's go to debugger. We have these here, buy some XP. So the baseline we have now is 274 for the nodes and 2342 for the objects, or 40 something. So if we run a battle, we have the spikes like we usually do. Let's follow through with the battle. Wait a second. The nodes go back to their original position, but now the objects kind of do as well because we saw that 2348 before. And if we go to the output tab, we have no state leakage here either. If we go back to the debugger, we have this nice flat line. If we execute another battle, we should, in theory, stop the leakage. Go back to the output window, the states don't leak anymore, and we have this nice flat line for the objects and the nodes as well. I think the number might be slightly a bit different, but I don't think it really has to do anything now with the things that we did, because if we wait for a while, it goes back to its original state and it's close to flat. I don't see any clear telling sign that we have these consistently growing number of objects like we had before. Right? We conclude another battle. Nodes go back to the same. The objects go back to kind of the same state, but if we wait a while, they'll go back to this 2340 something. It takes a while that it goes back, but it kind of remains roughly the same. I would say that this was for sure a memory leak and we fixed it because we don't have any output messages, right? We have just item descriptions, but the states are empty. I'm not saying there are no other memory leaks. There might be, but this was the really clearly visible and clear telling sign that we do have something going on. I think that's fine. So if we run another battle, we stay at roughly the same position. You could see that for a sec it went back to 46 again. And we don't really see a clearly visible increase in memory usage either. Right? So we go back again to that 48. Hopefully this was a cool learning experience for you as well. I really enjoyed hunting down that memory leak. It was not something I ever done before, so I hope it made sense how I explained my logic behind it and how we solved it. And this pretty much concludes the whole series. One final thing we need to do is to get rid of all the debugging statements and prints that we have. So first of all, let's go back to the battle handler and we can get rid of that reference counting thingy. The cleanup file just needs to have these 4 lines of code. Save this with Control S. Let's go back to the state. Also get rid of tracking all the object IDs with the static variable and that line of code here. Save this. And now we can just press Ctrl Shift F and search for print opening brackets to have all these print statements deleted. Now, these are from templates, so we don't really care about those. But we do have these equipped items that we can get rid of. We no longer need to print those out because we have tooltips now. Let's save this. And the 2 remaining ones that we have is something that we didn't do with the item handlers, handling whether we can spawn new items when we already have a full bench. It's out of the scope of what I wanted to do, and I'll leave those in for you if you want to keep working on the project. Here you could display a pop-up message or handle any way you wanted to, and here also either a pop-up message or do something else, how you want to handle your items in game. Now if we go back to 2D view, we can do one final playthrough of the game, but to do that, actually I want to turn off all the debug messages to see how it feels like playing it for one final time. We can hide the unit navigation debug node, save it with Control S, go to our battle unit scene and hide the FSM debug label too. Save that with Control S. And I have the music muted for a while now because I was a bit tired listening to the same track, but let's turn it on for one final time here. Save it with Control S. And let's see how the gameplay feels for one final time. So let's buy some units, let's buy some XP. Let's make level 2 Björn if I can. Oops. Now let's buy one more. Okay, let's put in the Robin, put in the Björn, and maybe another Robin, and let's see if they can beat them without any major items. Let's put some 80 on Björn. And you know what, let's put some rings on Robin. It doesn't really do anything. We have the descriptions now, and let's just see how that battle unfolds. Maybe buy a couple Robins in the meantime to keep building for a higher tier unit. And I pretty much won. The unit combiner turns on again. I have a tier 3 Robin now, and I can just keep playing those battles. It feels nice. It feels complete in a sense, even though it's just an MVP. But I think we created a great system and a great game that you can build on if you want to do a full-on project with this skeleton. A big warm thank you for everyone who came along on this ride. Hopefully you learned something and enjoyed that bug fixing episode and hunting down that memory leak as well. And I guess I'll see you in the next one. Bye bye.